Good day everyone, I'm Mr. Florendo, your Algebra 1 teacher. Today, week 12, we will discuss about Chapter 10, lesson number 4, solving radical equations, that is on textbook 633 to 638. Materials needed: your textbook, your notebook, and of course, your pen. Our objectives: the first one, to define a radical equations. Second, solve radical equations. Fourth, identify extraneous solution. Let's define first what's a radical equation. When we say a radical equation, it is an equation that has a variable in a radicand. When we say radicand, that is the expression underneath the radical symbol or square root symbol. Example: the square root of x minus 5 equals to 4. Since we do have the radical symbol and the variable x is underneath, this is an example of a radical equations. You can also have an equations wherein in the given, both sides has a radical symbol. Let's have this first example. Solve each equation and then check your answer. First, the square root of x minus 5 equals to 4. How we're going to solve this radical equation? Square root of x minus 5 equals to 4. We're going to isolate the radical expression. So to isolate the radical expression, we simply add both sides by 5 to isolate the radical expression. So we will have that one, the square root of x minus 5 plus 5 equals to the square root of x equals to 4 plus 5, that is 9. We isolated already the radical expression on the left. Then after that, square each side. So square the left and the right. So we will come up with this expression, and the result would be x equals to the square root of 9, that is 81. So let's check this value of your x if that one will satisfy to the given radical equation. So to check for that one, we simply replace or substitute the value of your x into the original equation. So we will have square root of the value of your x is 81 minus 5, it must be equal to 4. So the square root of 81 is 9 minus 5, it must be equal to 4. Then simplifying, 4 equals to 4. Since that is equal to 4, therefore 81 is a solution to this radical equation. Another example. The square root of x minus 5 equals to 4. So the first thing that we're going to examine into the given equation is that if the radical expression is being isolated already in one particular side. So in this case, it is being isolated already. So what we're going to do is simply square both sides already. So we will come up with this one. The square of the left side would be x minus 5 equals 2, and the square of the right side, that could be 16. Solving for x, we're going to add both sides by 5, and we will get x equals to 21. Check that one from the original equation. So we're going to replace the value of your x by 21 and then simplify that one. So x equals to the square root of 21 minus 5, it must be equal to 4. 21 minus 5, that is square root of 16, it must be equal to 4. And the square root of 16 is 4 equals to 4. Since that is true, therefore 21 is a solution to this radical equation. Another example. On a roller coaster ride, your speed in a loop depends on the height of the hill you have just come down and the radius of the loop in feet. The equation v equals to 8 times the square root of h minus 2r gives the velocity in feet per second of a car at the top of the loop. The loop on a roller coaster ride has a radius of 18 feet. Your car has a velocity of 120 feet per second at the top of the loop. How high is the hill of the loop you have just come down before going into the loop? So if we're going to illustrate the problem, it looks like this one already. This is the height of the mountain and this is the radius of the loop. This is your car already. The car velocity is given. So based on the problem, let us identify first what are the given. So we are given already the radius of the loop, that is 18 feet. We are given already the velocity of the car. Okay, the velocity of the car, that is 120 feet per second. And we are given already the formula for the velocity of the car, that is V equals to 8 times the square root of h minus 2r, wherein your h is actually the missing, that is the height of the hill, and we are given the velocity of the car, that is 120 feet per second, and the radius of the loop, that is 18. So you are asked to find how high is the hill. So simply replace that one into the given formula. So we will have that one as the velocity of the car, that is 120 equals to 8 times the square root of h minus 2, the radius of the loop, that is 18. So we just simply substitute that one into the formula. After that, we're going to isolate our radical expression. So to isolate that one, we're going to divide each side by 8 to isolate the radical. So dividing both sides by 8, we will have that one as 120 divided by 8, that is 15, equals to, divide the right side by 8, I will have only the square root of h minus 36. This 36 we multiply 2 times 18. Since the radical expression here is being isolated already, to solve for the unknown variable, just square both sides. So square 15 and then square the square root of h minus 36. We will have the square of 15, that is 225, equals to the square root of h minus 36, that is h minus 36. So solving for h, we're going to add both sides by 36. So I will have 225 plus 36, that is 261, equals to h. So therefore, the hill is 261 feet high. Another example. Solve the square root of 3x minus 4 equals to the square root of 2x plus 3. So the difference these particular radical equations compared to example number 1 is that both sides has a radical symbol. So what we're going to do, since the two sides has a radical symbol, we cannot isolate that one already. It is already isolated. So what we're going to do is simply square both sides. So squaring both sides, I will have the square of the left side, that could be 3x minus 4, and then the square on the right side, that is 2x plus 3. So simplify this one by add 4 to each side to isolate 3x on the left side, that is 3x equals to 2x plus 3, and then plus 4, that could be 7. Then subtract 2x from each side to solve for your x. So 3x minus 2x, that is x, equals to 2x minus 2x, that is 0, plus 7, that is x equals to 7. So check that one from the original equation. So I will have replace or substitute your value of your x, which is 7. So I will have the square root of 3 times 7 minus 4 must be equal to the square root of 2 times 7 plus 3. Simplifying the radicand, I will have that one 3 times 7 minus 21, that is square root of 17, equals to 2 times 7 plus 3, that is also equal to square root of 17. Since both are equal, therefore 7 is a solution to this radical equation. So the solution is 7. Another example. X equals to the square root of x plus 12. As you can see in this radical equation, the radical symbol is being isolated already. So if that would be the case, simply square both sides already. Square the left side, that is x. Square the right side, the square root of x plus 12. So we will have that one, x squared equals to x plus 12. Observe the result of squaring both sides. So we come up with a quadratic equations already, quadratic polynomial. Since this is a quadratic polynomial or equations, we can solve this one in different ways. You can try factoring method if that is factorable. You can try the completing the square. You can try that one by quadratic formula. You can try that one by graphing, or you can try the square root method. So there are 4 ways to do that one. So in order to solve this one, this quadratic equation, the first step is to write this one in standard form. When we write this one in standard form, the right side must be 0. So simply transpose the expression on the right to the left side. So we will have that one as x squared minus x minus 12 equals to 0. Observe the quadratic equation if that is factorable. Can we find factors of negative 12 whose sum is negative 1? Yes, we can find that one. So we will have negative 4 and positive 3 are the factors of negative 12 that would give us a sum of negative 1. So factoring the left side, we will have x minus 4 times x plus 3 equals to 0. So use the zero product property. So x minus 4 equals to 0, or x plus 3 equals to 0. Then solve for your x. Transpose 4 to the other side, that is x equals to 4. The other one, x equals to negative 3. So check from the original equation. Substitute the value of your x. So we can do this one. The first value of your x is 4. So 4 must be equal to the square root of 4 plus 12. And the other one, that is negative 3, it must be equal to the square root of negative 3 plus 12. Simplifying that one, 4 equals to the square root of 4 plus 12, that is 16, and the square root of 16 is 4. So that is true when your x is equal to 4. So the second value of your x is negative 3 plus 9 plus 12, that is square root of 9. And what is the square root of 9? That is 3. Negative 3 is not equal to positive 3. So therefore, the solution to the original equation is only 4. And the value of your x, which is negative 3, we call this one as extraneous solution. When we say extraneous solution, that is the current or apparent value of the variable that does not satisfy to the given radical equation. Another example. The square root of 3x plus 8 equals to 2. So the first thing that we're going to examine from the radical equation is that, is the radical symbol being isolated already? So in this case, it is not. So to isolate that one, we are going to subtract both sides by 8. So doing that one, we will come up the square root of 3x plus 8 minus 8, that is 0. So we will have square root of 3x equals 2. 2 minus 8, that is negative 6. Since the radical expression here is being isolated, square both sides. So squaring the left and the right side, so we will come up as the square of the square root of 3x, that is 3x equals to the square of negative 6, that is positive 36. So to solve for your x here, divide that one by 3. So x therefore equals to 12. Check that one from the original equation. Replace the value of your x. So the square root of 3 times x, which is 12, that could be 36 plus 8. It must be equal to 2. So the square root of 36, that is 6, plus 8, it must be equal to 2. But 6 plus 8 is not equal to 2. So therefore, 12 is not a solution to this radical equation. So we call this value of your x as the extraneous solution. How do we solve radical equations? These are the steps. The first one, isolate the radical expression. If the radical expression is not being isolated, we're going to isolate that one by doing the inverse operation, or by adding or subtracting both sides. The second one, square both sides. And the third one, simplify to find for the value of your variable. For your exercises, please refer to your weekly plan and Pearson account. Thank you and God bless you.